Welcome to Global Trends. Please subscribe and hit the bell icon for more breaking updates. Imagine standing on a shore, gazing at a vast, endless ocean. In 1977, humanity did just that, casting two bottles into the cosmic sea, Voyager 1 and Voyager 2. These spacecraft were our eyes and ears, built to explore the unknown and carry a message from Earth. Their golden record held greetings, sounds, and music, a hopeful gesture to whoever might find it. Now, decades later, they've traveled farther than any human-made object, crossing into interstellar space. These twin explorers remind us, even as a tiny speck in the cosmos, we have the courage to shout, "We are here!" Why launch two robots into the abyss? Because exploration is in our DNA. In the 1970s, the outer planets, Jupiter, Saturn, Uranus, Neptune, were mysterious distant worlds. A rare planetary alignment occurring only once every 176 years offered a unique chance, a grand tour using gravity to slingshot from one planet to the next. It was a cosmic billiards game, too good to miss. Voyager's primary goal was scientific discovery, to study magnetic fields, atmospheres, rings, and especially the moons, potential homes for life. Each planet was a new frontier, each moon a new mystery. Voyager was packed with instruments, cameras, spectrometers, magnetometers, ready to reveal the unknown. But there was a deeper reason. Voyager was a statement of human ambition. Born in the Cold War, it transcended politics, becoming a mission for all humanity. By sending these probes into interstellar space, we planted a flag in the cosmos itself. We declared ourselves a species that dreams of the stars and dares to venture into the great unknown. Voyager was more than a mission. It was a promise to keep exploring. It was our way of saying, we look up and we go, and that spirit endures. The journey began with fire and ambition. Voyager 2 launched in August 1977, followed by Voyager 1, their first stop, Jupiter. They sent back the first close-up images of the Great Red Spot, revealing a storm larger than Earth. They discovered faint rings and dynamic moons, Io's erupting volcanoes, Europa's cracked ice hinting at a hidden ocean. Suddenly, the search for life had a new target, Europa's possible ocean beneath the ice. Next was Saturn. Voyager revealed its rings as thousands of braided ringlets shaped by tiny moons. Saturn's moon Titan was a world with a thick orange atmosphere like a frozen primordial Earth. After Saturn, the probes parted ways. Voyager 1 headed out of the solar system. Voyager 2 continued the grand tour. Voyager 2 became the only spacecraft to visit Uranus and Neptune. Uranus was a tilted, mysterious world. Neptune had the great dark spot and the fastest winds in the solar system. Triton, Neptune's moon, had geysers of nitrogen erupting from its frozen surface. Each encounter brought new wonders and rewrote our understanding of the solar system. The Voyagers transformed distant points of light into real dynamic worlds. They showed us that our solar system is stranger and more beautiful than we ever imagined. With every flyby, they expanded the boundaries of human knowledge. The grand tour was a triumph of curiosity and engineering, and it set the stage for the next phase, the journey into interstellar space. After their planetary encounters, the Voyager's cameras were turned off to save power. Their new destination, interstellar space, the vast emptiness beyond the sun's influence, they became our scouts, venturing into the unknown, racing against time as their power faded. The boundary they aimed for is called the heliopause, the edge of the sun's protective bubble. No one knew exactly where it was or what crossing it would mean. As the probes traveled farther, scientists listened for changes. The solar wind slowed, cosmic rays increased. It was like leaving the calm harbor of the solar system for the open ocean of the galaxy. The suspense grew. Would the probes survive long enough to cross the boundary? Voyager 1 was the first to detect the signs, a shift in particles, a new environment. The data told a dramatic story. Voyager 1 was on the verge of becoming the first human-made object to leave the solar system. Every day it traveled another 1.5 million kilometers farther from home. The control rooms at NASA were filled with anticipation and hope. The race was on. Could Voyager reach interstellar space before its power ran out? The answer would soon come in a final faint signal from the edge of forever. The moment of truth was near. In August 2012, after 35 years, Voyager 1 crossed the heliopause, entering interstellar space. But the mission wasn't over. For years, it sent back precious data from this new frontier. As power dwindled, engineers began shutting down instruments one by one. The final transmission was carefully planned, a last faint whisper from the void. On August 18, 2025, NASA prepared to receive Voyager 1's final signal, a packet of data from the plasma wave system, measuring the density of interstellar plasma. It wasn't a picture or a sound, but a final scientific reading from the galactic wilderness. In the control room, triumph mixed with melancholy. Decades of work culminating in this last message. The signal arrived, was processed, and confirmed. Voyager 1 had sent its last word. Then, the command was sent to turn off its transmitter forever, conserving the last power for its heaters. 22 hours later, silence confirmed the command was received. Voyager 1's voice was gone, a ghost ship, sailing silently through the Milky Way. Its golden record remains, a testament to our existence. The journey continues, even in silence. What did Voyager 1's final message reveal? The plasma wave system measured the density of the interstellar medium, the thin soup of particles between stars. The data confirmed interstellar space is denser and more dynamic than we thought, with its own weather and turbulence. This final reading anchored our models of the galaxy, like a weather report from a previously unreachable ocean. It helps us understand how our solar system interacts with the galaxy as we orbit the Milky Way. More than numbers, the final signal was a testament to human perseverance and ingenuity. A machine built in the 1970s with less computing power than a smartphone survived nearly 50 years and sent back meaningful data. The silence that followed is also data, a reminder of the vastness and isolation of space. Yet it's not a despairing silence, but one filled with potential. Voyager 1 is now a silent ambassador, a relic of our curiosity, still journeying through the stars. One day, it may pass another star, carrying our message. The final transmission was for us. The golden record is for the universe. Voyager's legacy is proof that we can reach beyond our world. Its journey inspires us to keep exploring. What does Voyager's journey mean for us? Its final transmission isn't an ending, it's a new beginning. Voyager proved we can reach the stars, transforming distant points of light into real places. Its discoveries, volcanic moons, subsurface oceans, the weather of interstellar space, are the foundation for future missions. The next generation of probes will go further, faster, and maybe even carry humans beyond our solar system. Voyager paved the way. Its final message is a call to action. There's a vast unexplored universe waiting. Our curiosity drives us to cross new frontiers, just as it did our ancestors. The universe is full of wonders, and the quest to understand it is our noblest adventure. As we reflect on Voyager's silent whisper, we should feel pride and hope. The journey is far from over, it has just begun. The stars are calling as they always have. Thanks to Voyager, we are more ready than ever to answer. The future of humanity is written in the stars. Let's go and read it.